Okay, so we are back in action. So we just talked about the probability distribution here and going through how to figure out what the probability distribution looks like. So we're going to zero in on discrete probability distributions for now because we're going to look at the binomial distribution before we look at the normal distribution. So we're going to look specifically at discrete probability distributions, and then we'll look even more specifically at one type of discrete probability distribution. But here, the probability distribution, we've said if you're going to have a probability distribution, it's got to add up the sum of all the probabilities, essentially has to add up to 1. And you can show that probability adding up to 1, or you can show the probabilities either with a table, you can show it in a graph, or you can actually show it in functional form. There's actually functions that can, if you plug the variables in, like the possibilities in, 0, 1, 2, whatever, will actually give you the probability associated with that particular event. So there's 3 ways to do it. So if we look at tables and graphs, those are relatively easy. We're going to look at a function. That binomial distribution is actually described by a function. So we can talk about that in a minute. But here's a question. Just a magazine store records the total number of magazines purchased by its customers in one day. So 23% bought 1, 38 2, and so on. You can read it. But the first question says, what's the random variable? So the random variable is the number of magazines sold. That's what they're measuring. Then it says make a probability distribution table. So because we've got the 23, 38, 21, 13, and 5, if you add those up, we got to make sure, first of all, they add up to 1. So 23 and 38, that's 50, 61, then 72, and then 13 and 5. So what we end up with, I was at 72 there, that's what, 85, that's 90, so 0, or did I must have added that up wrong. Anyway, you understand what I'm saying. 23, 38, 21, 13, and 5 adds up to 100, not 90. I don't know where I got that from. It's okay. I'll be all right. So there is a possibility that nobody buys a magazine, or somebody buys no magazines, but nobody did that. So that's why that probability is in there at 0. So you still list it as a possibility, but nobody did it because these add up to 100%. And it kind of makes sense, because why would you go to a magazine store if you weren't going to buy a magazine? Unless you just wanted to read them and then walk out. But anyway, there's our probability distribution table. Now, the question then is, how do I make that into a graph? And it basically becomes a histogram where the probability is the frequency. So you guys are used to doing histograms. We talked about doing the data is on the x-axis and the frequencies up here. So for a probability distribution, it's just the x value is down here still, whatever it is you're measuring, but the probability is on the y. So that's how you take that information and put it into either a table or a graph. Now, this isn't always given to you. Sometimes you're going to be given a situation asked to find the probabilities yourself based on some probability you know. For example, if we're going to roll a 6-sided die, we know that getting a 6 or a 5 or a 4 or a 3 or a 2 or a 1, they each have a probability of 1/6. So then we can figure out, okay, if I said I want a probability distribution for the number of 4s, if you're going to roll 3 dice, then you could figure that out. You could figure out, okay, well, I could have a 1 4, I could have 2 4s, I could have 3 4s, I could have no 4s, and you could figure out the probability of each one using a tree diagram, like we did back here, right? We actually used the tree diagram, took the probabilities, and then made the probability distribution table. So sometimes you're going to be given the probability distribution table, sometimes you're going to have to make it. Here's an example where we're given the probability distribution table, but we're missing a number. So it says Sally's number of hits in each softball match have the following probability distribution. First thing it says is state clearly what the random variable represents. That's very important because you need to know what it is you're measuring. So we're measuring what? We're measuring the number of hits. So we're going to say X is the number of hits per game. And then it says find K. Well, if I know these, all right, I don't trust myself to add up to 1 anymore, but I think I'll be okay. They have to add up to 1. So you add these, 0.1, that's 0.56, right? That's 0.7. And so on, and then you get 0.23 because we had 0.77. That's what these add up to finish my thought. I didn't add this last one. So you get 0.23. That's the probability in here. Okay, and then once you've actually got it represented, then you can use it to actually find probability. So if I want to know what's the probability at any given match that Sally's going to hit at least 2, that's what this is saying, right? At least 2 hits, then we have to add up 2, 3, 4, and 5. Okay? Or because we know they all add up to 1, we can add up these 2, which are less than 2, and then go 1 minus that. So we have 2 options. And I'll show you them both here. We can either go 1 minus the probability that x is less than 2, and that gives us 2 possibilities, right? It's either 0 or 1. So we just take these, add them together, and then subtract from 1, and we get 0.79. Or you can add them up from 2 up, right? So you can go 0.23, 0.46, 0.08, and 0.02, and you will also get 0.79. So you can do either one. I'll just write this in here just to finish the thought. But either way, you get the same answer. The issue is sometimes it's easier to do this because the calculation is smaller. Now, is it that hard to add up 4 numbers? Not really, but sometimes it's actually easier because you're only finding one number here. If I asked you, what's the probability that x is greater than or equal to 1, you'd have to add up 5 numbers, where you just have to go 1 minus the 0.07. So it's easier to do it that way some of the time. But it doesn't really matter. You can do it either way. Now, the other thing you're asked to find is this one. The probability that x is between 1 and 3. And so what we're going to do is we're just going to take 0.14 plus 0.23 plus 0.46. We're going to add those up. So that gives me 0.46, that's 0.6, that's 0.83. So most of the 83% of the time, she's going to have 1 to 3 hits, which is pretty good. So there you go. That's how you do a probability distribution for a discrete random variable. We're going to look again at a couple of other things to do with these. We're going to look at expectation, and then we're going to look at the binomial distribution. We're also going to look at how do you find the standard deviation of these things, but we're going to look specifically at the binomial distribution to do that. So I'm going to leave the video there, and then we'll look at expectation in the next video. See ya.